So in atomic structure, we want to understand an atom. And we need to understand also where an electron is in an atom. Now, we know that we have got an atom, alright? Got an atom like that. It has got the center which contains neutrons and protons. We know the charging of neutrons and protons. Neutrons have got a charge of 0, protons are positive. Now the protons which are positive attracts the electrons which are negative, which are found in the shells. Now these shells we draw, they are necessarily not lines. Okay, shells are necessarily not lines. You can think of your bedroom. I'll say Mwansa is in the bedroom. Now, if I say in the bedroom, I don't mean he's on the bed. It can be on any space in the bedroom. So that is how you get to think of shells also. So you have got first a shell. That is where we know that an electron is going to be found. But a shell is going to, we know the other name for a shell is energy level. Now a shell is also going to be divided, or it also has like rooms inside. And you have what we call subshells, which we can also say sub-levels. If we use energy level, we'll call them sub-levels. Alright. Now the sub-levels are also going to be a bit divided, and these are now going to give us orbitals. So think of this as being your house. Those are the shells. The subshells as being your, let's say, the different rooms of the house. And then you have got the orbital, which is actually your bed. Now we define an orbital as the space around the nucleus of an atom where the probability of finding an electron is maximum. When an electron is in the shell, the highest chance is that you are going to find the electron in an orbital. More like if you are in your house, the highest chances, if you are not in the sitting room, is that you are going to be found. If you are found, let's say, in your bedroom, the highest chances are that you are on your bed. Otherwise, if it is not on your bed, where else would you be? You can't just be standing randomly. Let's say if you are one who has got a let's say a chair in your room where you study from, the highest chances would be maybe would be either on a chair or on your bed. So you can define that as an orbital, a place or a space around the nucleus where the probability of finding an electron is maximum. Now we don't say the space where you're going to find an electron, where the probability of finding an electron is maximum. Because if you are in your room, it is not always that you're going to be on your bed or on your study chair. You can also be standing, for example, you're picking some clothes or something. So please, we need to know that. Now, the path taken by an electron as you get to move around the path, just the path that you are taking, is called an orbit. So the orbit is the path that is taken by the electron as it gets to move around the nucleus of an atom. An orbital is a space around the nucleus where the probability of finding an electron is maximum. Now, these electrons you are able to see are quantized. Okay. Electrons have got only a specific energy that they are able to carry in them. For example, this is called the first energy level. That will be called n is equal to 1. And then this is going to be equal to n is equal to 2. This is going to be n is equal to 3. So, for example, if this energy level, let's say it has 2 joules, let me just give that an example. This one has got 4 joules. This one has got 6 joules. The meaning of quantized is electrons can only take up energy in specific units. That's the meaning of quantized. So it's more like stairs. So something that is like this, an incline, this is not quantized because you can have different values, but stairs are quantized. So these electrons are able to jump between energy levels. They are able to jump between energy levels. And how does that happen? So an electron, let's say, which is in the first shell. Now, since I've said that, let me try to remove this. Let's say you have got an electron in the first shell. When you project energy, and in this case, we are going to say a photon. So you think of photons as units of energy. Okay, just like you have got atoms making up all living things, you say energy is made up of photons. Now, when you project a photon or energy on an electron, so when an electron gains energy, it jumps from a lower energy level to a higher energy level. Now, taking into account quantization of energy. So if the energy in the first energy level is 2 joules, next is 4 joules, the next is 6 joules. If I project exactly 4 joules of energy on the electron that is in the first energy level, the atom, I mean the electron, is going to jump from this energy level, it got into the next energy level. If I project 6 joules of energy to jump from the first energy level to the third energy level, now if I project 5 joules of energy on this electron, that energy will not affect this electron. Why? Because energy is quantized. Unless if this electron takes up energy in a certain unit, which are these. So anything more or below, it will just pass. That means it will not affect. So if you project 5 joules of energy, it is above 4, it is below 6. An electron cannot be found in this space. That's a quantization. And so that's why the energy will just be able to pass. All right. So that is one thing that we also need to know. At this point, do we have any questions first? Any question? Any question? Yes, go on. Okay. So we are saying when you project energy or a photon on an electron. Now, photons are units of all the electromagnetic waves. Remember, light is just part of the electromagnetic waves. You also have gamma rays, X rays, infrared. We are also supposed to know those. We'll talk about them as we get to go on. So when you project energy on an electron, it should be energy in a discrete unit, right? In a discrete unit. So if you project that kind of energy on an electron, it's going to jump from one energy level to the other. So if you have got an electron which is in this shell, it loses 4 joules of energy. Let's say it loses 2 joules of energy. It is an in 6 with 6 joules. It loses 2. It will have 4. So it's going to jump to this energy level. So when an electron loses energy, it drops from a higher energy level to a lower energy level. Okay. When an electron gains energy, it jumps from a lower energy level to a higher energy level. And this, what you are saying, is called the Bohr model. Bohr model of an atom. So the Bohr model is very, very important for us science students to understand. So there are some postulates or some ideas which Bohr gave, and some of those are the ones which I've just mentioned. When an electron gains energy, it jumps from energy levels, or it can transition. So if you hear the word transition, it just means to change energy levels. Now you take in energy of certain units. If it is below or above, that energy will not affect the atom. That is one postulate of Bohr. Electrons transition between energy levels. Now another thing about the Bohr's model, one postulate or one idea that Bohr gave is that electrons move around the nucleus following Coulomb's attraction of the electrons to the nucleus. That is another postulate. Electrons move around the nucleus following Coulomb's attraction. Now, if you talk of Coulomb, you should be able to think of electricity like the positive and the negative. So the reason as to why electrons are moving around the nucleus is because we've got positive things and these are negative, right? So they move following that attraction, the attraction of positive and negative things. Now, necessarily, the atom is not a circle as you are able to see. You can think of more like something like that, more oval. Another postulate of Bohr is that the the momentum, okay, the angular momentum of electrons is also quantized. If we what do we mean by angular momentum? Remember, momentum is simply mass in motion, and angular momentum is given by the symbol L. So the angular momentum of electrons is quantized. That means that an electron that is in this shell has got its own momentum. An electron that is in the shell has got its own momentum. So that means if you've got two electrons in the same shell, they should have the same angular momentum. In other words, they've got the same speed at which they move around that shell, in around the nucleus in that shell. That's the meaning. So each electron, the angular momentum of each orbital or of each shell is quantized. Let me say, not orbital, but of each shell is quantized. So at least we need to know some of these Bohr's models, postulates or ideas. Okay, transitioning, electrons moving due to Coulomb's attraction, and also quantization of the Bohr model. Do you have any question? Yes, please. Okay. So to be quantized just means you have got certain values. That's the meaning. So you can think of stairs like this. If you step there, the next you are going to step is here. You can't, if you don't have energy to step there, you'll not be able to move your leg because you can't step here. It's not possible. So that's the meaning of quantization. If you if this energy level, suppose electrons with 2 joules, and then an electron loses energy such that it only remains with 1 joule, it will not go to that energy level because that energy level only supports electrons with 2 joules. If an electron that is in that energy level gains 7 joules of energy, it will not come in this energy level. Let's say the next energy level, suppose 8 joules, it will not also go there, and that is something in between. So that energy will just be able to pass through the electron, and it will not affect that electron. Okay, so the only way an electron can transition between energy levels is if it gains a certain value of energy. If it gains a certain value of energy. So that is it. Is that okay? All right. Now, each electron in these shells we're able to see has got on element of quotient. So that means that each electron in each shell should have its own. Okay. So let's say we are talking of what is the equation anyway that relates the energy that an electron in a shell has. So that is being equal to RH, then we've got 1 over n squared. And here we're going to attach a negative. So this equation will give you the energy that an electron has in a certain energy level. Now the RH you are able to see is called the Rayleigh constant.